All right, we have graphed the function f of x in red. Grant gave us some coordinates, and now I need you to graph f negative 1. Okay, the inverse of f. I think Justin said he was going to help us. Please.
I don't think it's right.
Why not? Because your x's and your y's switch.
Yes.
Okay, so pick a point. Start with a point. Okay, which point did you start with on your f of x? Did you start with 1, negative 1?
No, I just thought you wanted me to start with 1.
Okay, but which point is this a reflection of?
This one.
1, negative 1. So this became negative 1. That's what I want to see. Okay. Then pick another point.
Well, 5, 2 is 2, 5.
So go to 2, 5.
Right?
Will you put coordinates? Yeah. Okay.
And 2, 1 is 1, 2. So that's here.
Uh-huh.
And then 1. I did that one. So then it's negative 2, 0.
Uh-huh.
So it's right there. And then negative 1, negative 4 is negative 4. So like here, negative 1.
Uh-huh. That's exactly what I'm looking for. I need to see the coordinates where you've switched them. That's okay. All right, now should you connect the dots somewhat of a reflection about what they are? Yeah. That looks amazing.
Thank you.
Good job. Okay. If we were to draw that y equals x, could we flip and it be on top of each other? Yes, we could. Okay. Inverse functions. Okay. This is in all math, inverse functions. Okay. Are we good? Can we now apply it to a trig function? All right. If I were to want to graph y equals sine x, I really don't want to do that. Let's do sketch. Can you graph y equals sine x? Yes.
Where's mine?
Before you came in, we realized that she was not here.
Where'd she go?
So, graphing y equals sine x. What are you doing? Where does it start? What are we going up to? What are we going down to? What's our sketch? We start at 0, 0. Then we go where?
It was like up to 1.
So we're going up to 1, down to 1. What happens? When are we up at 1? Pi over 2. I'm making an assumption that you remember this. Then we go to pi. Where are you at? 0. Then where do you go next? 3 pi over 2 is negative 1. And then 2 pi is back at 0. Is this the whole sine curve?
No,
it's just a part. What part is it?
It's 2 periods.
It's 1 period all the way to 2 pi. Does it continue to the right? What happens after 2 pi? It goes back up and then back down and then back up and then back down. It keeps going like that. What happens on the left side of 0? It goes down and then back up and then down and back up. It repeats. It never is not like that. Right? Okay? Is y equals sine x a function? Y Why is sine x a function? It passes the vertical line test. Is sine x a 1-to-1 function? What do we use to test is it a 1-to-1 function? The horizontal line test. Does it pass the horizontal line test? No, it does not. Could we do like we did with x squared and restrict our domain? Could we pull a piece, a section, where it would pass the horizontal line test?
It'd be a very small piece of it, but yeah.
But we can get kind of the whole flow of it, but where it doesn't repeat. So if I asked you just 0 to 2 pi, what if we took 0 to 2 pi?
It would fail.
It would fail. Okay, let's try something else. Anybody got any other ideas?
You have to do it. What about pi over 2 to 3
Pi
pi over 2?
over 2 to 3 pi over 2. Would it pass the horizontal line test?
I think it would. Indeed it would.
Okay. Could you, me, have done 3 pi over 2 to whatever that is?
Indeed you could have.
We could have done the purple section.
Oh,
Okay. Could we have done backwards? Okay. Any of those. How far is it from the beginning, meaning a trough to a crest, crest to a trough to a crest? How far are we going in any of that? Pi. Okay? So if we go 1 pi, take one section, 1 pi out of this, we can make it a horizontal, make it pass the horizontal line test and have a 1-to-1 function. Okay? I'm going to tell you they like to have 0, 0 in it. They like to have the origin. Okay? We could choose any one of these 3 or infinite number of other ones to graph. Okay? They like, meaning mathematician people, like to have the x, y axis there. So they like to see the origin, if you can. Okay? So we're going to take this piece here, and we're going to talk about just that piece. Okay? How far back do we have to go? What is this when we're at the bottom? If we went
negative pi over 2.
So if we went pi over 2 forward, we can go back pi over 2. So negative pi over 2 to pi over 2 is where we're going to restrict our domain. Okay?
What's up? Brian! Howdy.
We have recorded anyway, you could have. But we're going to move on and we're just going to graph. Y equals sine x with a restricted domain. Where are we restricting our domain to?
Negative pi over 2 to pi over 2.
So we're going to say x is a set of all real numbers such that x will be greater. Oh, is it going to be equal to also? Do I need to put an equal sign under there?
Equal what?
Equal negative pi over 2. Will it touch it?
Yeah.
Yeah, because at pi over 2 or negative pi over 2, we're at 1. So we want to put it equals. But it's less than or equal to pi over 2. Okay? So we're restricting our domain of sine so that it will have, oh, that's a negative 1 to 1. And we have a 0 in there. So 0, 0 is one of our points. Back here at negative pi over 2, where are we at? Negative 1. And then at a positive pi over 2, we're at positive 1. Okay? So So our sine curve kind of goes up like this, goes down like that, and we can pretend it was going on. Okay? That's not really there when we restrict our domain. Okay? Can somebody tell me the range? We haven't talked a ton about the range, but can you tell me what in the world am I in blue for? What is the range?
X, E, thing.
Well, range are our y's.
Yeah, it's
So-
just from negative 1 to 1.
Y is a set of all real numbers such that we are between 1 and negative 1. Okay?
Right.
But it equals, so we put the equal sign.
I have a thought.
Okay, wait just 1 second. Pause. I want everybody to at least write this down. You got your sign graph.
Yes.
What is this? Oh.
This is sine with a restricted domain. Yes, question.
Okay, so since it's now 1 to 1, and if you try and do said flipping
Inverse function.
inverse function,
It would
like
just make
our
it
only
X.
points are 0, 0, 1, 1.
No, oh, no, it's not 1, 1. This is pi over 2, 1.
Yes,
And negative pi over 2, negative 1.
never mind.
So we have, yes, do I need to list those coordinates? Yes. I have them on the x and the y axis, but I'm actually going to list the coordinates of my now 1, 2, 1 function.
That was my fault. I had a little brain fart.
That is okay, it happens. This morning 4 times 3 was 7 in my brain.
Yeah, sure.
It happened. And I actually wrote it down. They had to correct me. So over here, obviously, we are going to now graph y negative 1 or sine negative 1. I want you to graph the inverse sine. We have graphed sine with a restriction. We have 3 points. How many points should we show in our inverse?
3.
3.
So how high do I need
Okay.
to go?
Now, question is pi over 2. If you estimate that, that's 3 over 2, so it's about a 1 1/2. So it should be farther away than 1.
Yeah, the
This is
hard part
not
is-
drawn to scale.
Yeah.
That is why crucial that you label your points. Okay? Drawn to scale, I can't do. I don't expect you to do perfectly. I don't do it perfectly. What I do expect is you to go over to 1 and back to negative 1. You should have 0, 0. And then you should have, instead of pi over 2, 1, you should have 1 pi over 2. Yes? So this point over here is 1 pi over 2. I just took this point right here and flipped the x and the y. Just like we did with that very first one. Okay. The other one is negative pi over 2, negative 1. So we need to be at negative 1, negative pi over 2. Now, here's the point. Wait. Actually, there's 3 points there. There's 3 points here. What I want you to see, the sine curve, remember how I put those little dotted lines that it keeps going this way, then it keeps going this way, that's where it goes, okay? When we are flipping or reflecting across the y equals x line, this graph, it will curve more this way because it will continue to go up the y-axis if we were to flip. So it would continue to go the y-axis.
How do you know which way to draw it?
Okay. Meaning this little curvy piece right here.
Yes, ma'am.
Okay. I just said sine is the curve around the x-axis. The inverse is going to be the curve around the y-axis. want to get into lots of, pi over 4. Where are we? Okay, because it's not going to be. That's the inverse sign. It puts a little -1 up there. No. Sine -1 has never been cosine. 1 divided by sine is cosine.
What is that?
No, it does not. It never has.
Is that too?
No.
Oh,
No. No.
It's
When-
like one over sine.
Is.
It's sine negative.
No.
Cosine.
No. No. Never has been. Okay? When have we used this sine -1?
It's
And
to
our
find
function.
the angle.
To find an angle. We have never used sine -1 for cosecant. Ever. Okay? We find it if we need to know an angle. You have sine x equals 3/4. You use sine -1 to do that. Okay? That is not a secant or a cosecant thing. Okay? It's an inverse function. When we were plugging these into your calculator, there was a big note that said sine -1 is not 1 over sine. Okay? Alright. Are we okay? These graphs, my kids in calculus still have to graph these. Graph the inverse sine right now. Okay? We're going to work with them more. Okay? But this will not change. I'm never going to add anything else to this. Here's our restricted domain, and we came with a range. Can you graph its inverse when we restrict it to be a 1-to-1 function? I am going to ask you another question. The inverse function, what is its domain? Domain, what are we putting in? Meaning our x values. Do you agree? Our x values are going between -1 and 1. So x is a set of all real numbers such that what? -1 less than or equal to x less than or equal to +1. We're going to pretend I have room there on the edge. What is the range of the inverse function?
Mine is literally exactly like yours.
Wow. Can I give you a huge major hint?
Yes.
These are the exact questions on your next quiz.
Really?
It can't change. So, do I need these in my notes? 100%. Okay, so what is the range? What are we getting out?
Negative pi over 2.
Y is a set of all real numbers such that, what? Negative pi over 2,
Oh,
less than or equal to y, less than or equal to pi over 2.
so you don't like continue it? Like you stop entirely?
Yes, because if you look back here at your sine function, that lovely gray curve, or this lovely yellow curve, is that a 1-to-1 function?
No.
Does it pass the vertical line test? Yes. Does it pass the horizontal line test? No, because it curves back
So you
there.
have to stop.
So we had to restrict. That's what we did right before you got it. We restricted the domain, the input, to just be between negative pi over 2 and pi over 2. We took a section. Whichever we could do, take different sections. The mathematicians like to have the 0, 0 in there.
Okay.
They want that. Okay? So this will not change. Do you recognize something about the domain and range of the inverse functions?
They're just the opposites of
Okay, so when I read in that green box that didn't make any sense 2 days ago, the domain of the function will be the range of its inverse.
Hey, look at that.
The range of the function will be the domain of its inverse.
Hey, look at
The x and the y's are switched.
that. Who would've thunk it?
Wow.
Have there ever been any theories that they thought were true and then realized they didn't work? Like, that they taught in school?
By the time it's in a book, it's been tested a lot.
Anything new?
It is beyond tested. Okay, so we're going to do the same process with y equals cosine x. Can you graph y equals cosine x?
Yes.
I'm still on eraser. Alright, graph your sketch of cosine x. Tell me where in the world, because you can probably guess by now, is the cosine curve a one-to-one function? It is not. But where does the cosine function start? At 1. And then where does it go? It goes to 0. Where?
There goes down to negative 1.
To pi over 2. Where is it at negative 1? What's the x value?
It is
Pi.
pi
Then it goes back up,
to 3 pi over 2.
and then it goes back up to 1
That's 2 pi.
at 2 pi. So if we were to graph this, we know that it would continue, yes? Okay, we're going to keep it going that way. Is it going to keep going back to the left? Yeah, it's going to keep going back that direction. Is there a spot, a good spot, to restrict the domain? Are we still going to restrict cosine to negative pi over 2 to pi over 2? If we restricted it from here to here, oh, that is not the right spot for that stop. Woo! We're going to erase that line. Then we're going to go back and turn my brain back on to pi over 2, negative pi over 2. So are we going to restrict from negative pi over 2 to pi over 2? Is that a one-to-one function? No.
Because like I can do this.
Because you can do this all day long and it doesn't pass the horizontal line test.
That's facts.
That is a fact. Okay, we're going to just pretend, because I know I did a lot of other stuff.
But you know what you can do?
What can you do, Tyler?
You can go from 0 to pi, and it works.
Could you go from 0 to pi
Oh my god.
and it be a one-to-one function?
Wow.
We done did it, guys.
All right.
Way to go, Tyler.
Now,
You're really the MVP of this class.
No, this is a team. This is a team. There's
Yeah.
no I in team, and we're a team.
at least,
I'm just the vocal leader.
yeah.
They're doing all the work.
I love, like, another class, they like to shout out such and such for math award. Like, whoever's talking and doing stuff, they always shout out who's going to have math award. So I'm going to go ahead and erase this and just not go to another page. So I'm erasing. I don't want any of this stuff over here. So where are we restricting? I don't want this stuff back this way. So if we restrict our domain to be from 0 to pi, is it a one-to-one function?
Yes.
Yes. Cosine will always have an inverse with this domain. So wait, let's go ahead and tell me, what is the domain?
X are real numbers such that. That means 0
Such that what?
between
Between 0 is equal to 0 and x and pi.
I like pi.
Yeah, there's been a lot of talk about pi.
What is pi?
March the 14th, every year.
Breathe.
We're always on spring break.
Oh, it's my brother's birthday.
We should celebrate
When's spring break? How many weeks do we have?
Dos.
3.
We got week of March, last week of February, and next week is parent teacher conference.
I love
There's 3 weeks and 2 days left.
Oh,
I thought
just
it
spring break.
Still spring
I
break.
thought you meant of spring break, and I was like, what?
No. And then spring break, and we have 2 weeks off. Alright, what is the range?
The range is you make 1 to 1 or do that letter thing.
Why is a set of all real numbers such that?
Negative, yeah. Good job, Malls.
I'm going to go ahead and put my coordinates, which I haven't really done. I put some X values, I put some Y values, but I haven't really listed coordinates. What is this coordinate right here?
0,
0, 1. What is this coordinate?
5 over 2, 0.
Okay. I like to list them. What is this one?
Hi. Yes, Taylor.
Yeah, Taylor.
So can you sketch the graph of the inverse cosine function? Never mind. I was going to try to move, but I'm not going to. What color are we going to do the inverse in? Green? So can you graph cosine?
Oh.
Yes. You need to write this down. This must be in your notes.
And you said pi over 2 is basically
1.5.
if we graph it as like this one.
Sometimes you'll see the Y values just need to go on the X values. So I'm going from -1 to 1. Right? I'm going, what's my X values need to go to the Y values. So my X values here started at 0, pi, so they need to come out Y values. From what?
My domain and range, like when you glance at it, it looks like hieroglyphics.
Okay.
Do the same.
Like, wow. This is some fancy stuff.
Yes, I will tell you a funny story. I was finishing up grading some of y'all's stuff the other day, like the pop quiz stuff that I still hadn't done. They're in the computer now, if you want them back. I mean, but I was grading through and I was going through them. The basketball game where I sat for 45 minutes in the stands to get here to get a ticket and get a seat. But I ended up sitting by McMurray's, Nana Papa. So I
Nana and
sat-
Papa?
Yes,
I
but
love them.
Papa was sitting beside me. He had his earbuds in and he's reading a book. Okay.
In the middle of the game.
Well, it was before the game started. But yes, he will bring things to do during basketball games. Yes. So I'm grading stuff and he's watching me. He is a math person. Okay. He says, do you require them to write things in terms of sine and cosine before they do this stuff? Like, we were having a lovely math conversation.
Miss Evans.
Okay, so have you graphed? 1, 0. 0 pi over 2. And -1 pi. Is this what your graph looks like? So you went from 0, 1 to 1, 0. Yes? You went from pi over 2, 0 to 0 pi over 2. Then you went from pi, -1, to -1 pi. Should it go where it's going to continue to go that way, here, and pretend it's going this way?
Yes.
I need you to finish this graph and tell me what's the domain and range. That is your homework. Alright?
Thank you.
You are welcome. Woo! Oh yes. Still. Goodbye. Still.